thank you for joining us today. Hope you're having a great day. My name is Gokul, and as part of the product team here at Vectra, I focus on stopping identity-centric threats and attacks in enterprise clouds. So as organizations of all sizes today, across industries, increasingly embrace the cloud and the cloud way of software development, things like daily updates and decentralized control where applications teams push to production independently. Security teams are generally struggling to keep up. So today we will walk through and talk about how defenders of organizations with a hybrid cloud, multi-cloud footprint using multiple products from the Microsoft suite can stay ahead. So let us start with an example of a real world um, attack to understand the key characteristics of modern attacks. Yeah. So if you think about just the Mango Sandstorm attack, which has been in the news recently, the Microsoft threat surface spans across a huge expanse. So there is your on-premise servers, there is on-premise identity, Active Directory, there is the federated cloud identity, Entra ID, there is all of the productivity application suite in Microsoft 365, and then there is the Azure cloud. So this is a breadth of resources and users that are so deeply connected. And this is exactly what attackers have been able to exploit. So the attacker first, found a piece of network infrastructure that was publicly exposed and had vulnerabilities, deployed malware to establish a foothold, and then had a command and control channel going back to controlled endpoints. So then from this piece of infrastructure, the attacker was able to extract credentials and used those credentials to move laterally. The attacker discovered this federation service, and thereby, the same user, the same entity has an Active Directory identity and Entra ID federation, and was able to move into Entra ID, which happened to be the identity provider for all SaaS and cloud services for the organizations. So thereon, the attacker had two paths. First, the attacker moved into Microsoft 365, was able to access those apps, essentially inserted them. There's a number of things an attacker can do, whether it is automated forwarding rules, or in this case, it was essentially sending out emails impersonating someone else. And all this to get more credentials. And then from there, the attacker also moved with those credentials into the Azure cloud, was able to discover what was there, and then impact exfil data. Right? So this was the classic fingerprint of the Mango Sandstorm attack. The key themes here that are representative of these modern attacks is firstly, hybrid enterprises are targets of hybrid attacks. Right? We just spoke about that. The second is interesting. The network is not necessarily always the perimeter. The identity is the new perimeter. Right? And the third is that prevention is necessary but not sufficient. Preventive measures like posture checks and things like that are good to have, but they will fail, especially when there is an authorized credential that is compromised outside of the cloud. Right? So these are three things that distinguish modern attacks from the traditional attacks. So then in that world, what does that mean? The broader theme here, like I said, identity is the new perimeter. Identity-based attacks, unlike the traditional, server-based attacks, etc., identity-based attacks can be really shallow because it's literally discovering permissions and then calling documented APIs. As a result, they're not too many layers deep. They don't need to be. They're also fast and broad, giving defenders less time to respond, right? So as a result, it's not surprising that identity compromise is the number one attack vector in cloud data breaches. Turns out, while it is the fastest to execute, because the credentials are authorized, it takes the longest to detect. And as a result of how much access any generally credentials have, that's the volume of data at risk. And so the cost of breaches, and this is an average number um, across a few hundred reported incidents, is over $5 million. So you can imagine the larger the organization, the larger the payout. Right? That's number one. Number two, under time pressure, the current approach of having siloed tools is just not adequate. One has to go, if you looked at that attack surface, one has to go across 3-4 different tools to piece it together and figure out what belongs together, what's part of the same attack, and how urgent is it. And generally, because all of the tools are looking at point threat surfaces, it results in an unmanageable alert volume, and the more that results in defenders falling further behind. Right. So that's sort of the bane of attacks in the cloud. So what does one need? Right? Firstly, in the Microsoft Cloud universe, the Defender suite and Sentinel as the data lake, they offer really good endpoint coverage, email, and they offer some level of identity coverage as well. The strength of Defender for Cloud is in posture management, which is making sure avoidable misconfigurations are completely shut down, and that doesn't become an initial attack vector. Compared to even 3 years ago when misconfiguration was the biggest source of attacks, now it's no longer that. So good thing there. And then all of the threat intel and anomaly detection, I think there are capabilities that are just available and can be used. Now, what the SOC needs is that connective tissue, the ability to detect threats across all these different environments, and then be able to stitch those together with two primary angles. First is stitch together credential-based attacks, and then stitch together credential-based attacks, and then have that visibility across threat surfaces. So then the next set of capabilities has to do with investigating those attacks. It cannot be just raise a few flags and then leave the defender at the mercy of a data lake with its specialized query languages and whatnot. It has to be very rapidly keeping pace with the attacker, if you will, in cases like this. So this is what a SOC needs. Now, let's take a quick second and see what that could look like. Right? So fundamentally, here's an attack that we observed unfolding at one of the sites where we've been interacting with, a customer site, a large global FinTech organization. And so we replicated that scenario here to see how Vectra would perform. And that is what I want to walk you through. Right? So here the attack began with initial access to Azure using a compromised identity with essentially a reader's role. Now, reconnaissance in Azure was performed, but it's generally hard to see because those are not logged, unlike in some other clouds. Then the attacker moved laterally to Entra ID, and that's sort of the orange box, and started performing once again two things. One, recon the permissions in Entra ID, and then abusing group management to escalate their privileges in Azure. Finally, the attacker gets into a privileged role and then starts turning off defensive capabilities in Azure, diagnostic logging on certain resources and so on. And then finally, the attacker is able to generate a storage access service token, a SaaS token for exfiltrating sensitive data from the storage account itself. So this is how an attack essentially unfolded. We were able to catch it long before it got to this. And I'll just show you how that came about. But once again, the key here is literally less than half an hour from the initial compromise all the way to exfiltration. So I'm going to switch screens and okay, perfect. So this is the respond user interface for the Vectra's platform. And so what you see here is a list of prioritized entities. And prioritized entities are essentially entities that Vectra is calling to your immediate attention. Right? So there is no ambiguity in this. Generally, the guidance is just start at the top, work your way to the bottom, make sure you have no reds for sure, right? Now, what am I seeing here? I'm seeing 3 accounts here, each of which have been scored at 97 and fundamentally begging to be investigated. So let's pick Mark Ranger. We could have picked the other one as well, but I'm going to pick Mark Ranger here. And here you see there is a series of behaviors. And these behaviors essentially mirror that attack progression we spoke about. We'll see how in just a second. Okay, so before we go into that, what it's saying is I've seen detections in Azure Cloud, Azure Identity, and Microsoft 365. We've determined that because this entity based on its access is medium in importance, and then based on the behaviors we've seen, this attack rating to be an external adversary, and we've scored the attack at 10 on 10 because we combined this information with the fact that the attack is progressing really fast. So the velocity is high. So the behavior seen, the importance of the entity, the speed at which it is progressing together inform us that the attack rating is a 10 on 10 and it needs to be looked at right away. So now, if we were to dive in, this is where you'd land. So before we go into the details of each of these detections, let's just look at the details of the account itself. So what clearly you're seeing here is the same account seen in Azure AD and on the cloud. So slightly different designations, but because we were looking for those and able to stitch those together, we've essentially been able to correlate the behaviors across Azure AD and the Azure cloud. Okay, so now if we expand all of these behaviors, we see essentially the sequence we were looking for. First, there was the attacker logging in to access Azure from an AWS cloud IP, which is rather unusual in this environment, right? The next thing to see here is once that was done, before any of that, in Azure AD, there was, we said it was exposed externally, and so there's a scripting engine. The attacker was able to create credentials and leave them there that would give them access in case this set of credentials was shut down. And so we know where that is going. We saw then that there's suspicious access from the AWS cloud moving through. Once the attacker is in Azure, there is a group membership modification whereby the attacker got administrative privileges. And then once they have administrative privileges, so they first were just able to join a group through Entra ID. And now they have administrative privileges of that group. Now that they have that, the attacker is able to create policies that govern access, and also disabling policies that are meant to be protective in nature. And then we start looking at remediation tasks. This is basically deploying stuff, and then if someone resets it, a remediation task can essentially go and reinstall or reinstate the privileges that the attacker had. Right? So all of these behaviors are just caught very early on, and that's not all. So now for any of these detections, so first is for this account, I would want to know what else the attacker did. We've flagged, Vectra has flagged these behaviors, but what else did the attacker do using that account? So that's where we go to instant investigation. These are obvious questions. So you should not have to craft a query, put it into some data lake in some query language, and then get a bunch of a table and then have to make sense of it. Right? Like these are just questions every single time you want to investigate an account, you should just have at your fingertips. And that's what we're trying to do here. So we see that this Azure account has seen logins from Oregon and then suddenly London. That should raise eyebrows. And then Azure AD activity, you see a whole bunch of secrets management changes. There's user management changes. So this is also unusual. Like very little other exchange activity, just permissions activity is what we are seeing here. And then updating passwords. So essentially every single action that cumulatively flagged those detections is recorded here. And you want the very raw logs, we can pull those up as well. Right? This was exactly the properties modified and whether it was successful or not. So this was everything in Azure AD. We can now very easily switch over to the Azure cloud and see what was done. A bunch of role assignments, listing of storage account keys, remediation policy, everything that we expected to see. The details are right here. And then the tools used, it's clear Azure CLI was what the attacker used from that external IP to come and make all these changes. So literally in minutes now, we've basically traced the path of the attacker as they've gone through these different environments. Right? And then should we choose to go deeper, for any of the detections, I can click on investigate further. And this is what we call advanced investigations. where you can craft your own queries, and we give you a formatted version of the raw logs, but with specific enrichments and enrichments that make it easy to read. And these are, for example, I will add actor as a column. So now, you don't have to deal with figuring out who this object ID belongs to. Right away, we've done that mapping, and we've told you it is Mark Ranger. Right? So usually this thing, which is given a log record, I have to first translate it in Entra ID to see which user account it resolves to, then figure out what other user accounts this same account is tied to, collect all those object IDs, and then run an operation whereby I figure out, I interleave all of those actions and piece together a story. So with enrichments like this actor ID, you now have the full picture right in front of you. Okay, and then with Entra ID, directly from the Vectra platform, should you choose to, you can remediate, you can lock down an Azure account, and then that way you've stopped the threat in its tracks. Okay. So this was a brief walkthrough of how Vectra can help in these multi-threat, in this hybrid threat surface involving Microsoft. Okay, so I'm going to stop sharing. And go back to just confirming that the slides are showing back up again.
Good to go.
Great. So yeah, this is essentially how the Vectra product or the Vectra platform essentially reduces a complex investigation to minutes and clicks with all of the high fidelity data required to close out an investigation. But what you saw is just a trailer. It's one set of behaviors that we look for. That's not all. We have a comprehensive portfolio of detections that cover multiple tactics through the attacker's progression. We've carefully curated this to be a combination of, of course, attacks seen in the wild, like Scattered Spider, Mango Sandstorm, Peach Sandstorm, Midnight Blizzard, all of those. We've also ensured that all of the commonly known tools that attacker may use, those behaviors are captured. We've ensured that it's taking into account previously unseen threats that our security research has surfaced. And so we feel very confident in this portfolio of detections, especially when it is in combination with the broader Vectra portfolio, right? So fundamentally, you have coverage across all of these different elements of your hybrid threat surface, nearly 200 threat behaviors, and going across all tactics in the progression of an attack. Right? So with this, combined with the ability to correlate attack behaviors prioritize them based on combinations of these behaviors, investigate in minutes, and then be able to lock down those compromised elements. This is the fastest way to get ahead of attacks on the Microsoft threat surface. Okay. So, it's not just a saying it. We've basically put ourselves through the ringer. We said, hey, what would we do if Scattered Spider were unfolding? And so, simulated this series of attack behaviors on a real life vulnerable infrastructure, and then we were able to catch all behaviors through the progression. Not that, take BlueBleed, which is essentially a different kind of impact. This is more, deleting resources en masse. And so we were able to capture a number of activities there as well. And then Pete Sandstorm, this was a reverse, which was coming back from cloud to the data center. So we were not covering the data center in this case, but all of the activity, especially when you look at the hybrid automation workers and services like that, we were able to capture them successfully. And then also, so these are all demonstration of what we can do. But yeah, I mean, in summary, so yeah, in summary, what Vectra is able to offer is coverage across all these different threat surfaces. We are able to uncover and detect attack behaviors with very, very high fidelity, and involving both hosts and identities, identities including human identities and machine identities. The second, we're able to offer the clarity for investigators to be able to prioritize what they do. So tying those back, connecting the dots across these attack surfaces, and then be able to attribute it to actionable entities, and then prioritize them so that you have the most efficient method to go through it. And finally, control, as a way to stop those threats. All the data and the tools to investigate in minutes, and stop attacks in their track. So this is sort of how we do it the Vectra way. I would urge you to trust but verify. And towards that, if you're wondering what it takes to get this going in your environment, we would welcome you to. So first and foremost, just reach out to your Vectra team or reach out through our website, and we can get you set up really quickly. The onboarding for Azure coverage is very simple. First and foremost, you just grant consent, to the Vectra app to access Azure. Once that is done, we set up logging ourselves. One of the hardest parts in Azure is that you have to go and enable activity logging and enable resource logging explicitly per resource type. And so we are helping with just a single click ARM template that automates logging itself. And then we also have policies to make sure that any new subscriptions that or resources of those types that are brought online, automatically coverage is extended. So what this does is now all these logs come to a single storage account, and then you basically grant the Vectra app access to that storage account, and then back on the Vectra platform, you say, where do you pick those logs up from? So all in all, it is, less than an hour to set up coverage for the entire footprint, in terms of time spent at the keyboard. And there is something called a remediation policy that runs. So we basically, once that window is done, which can take a few hours, you will start to see logs flowing into the Vectra platform. Right? So that's fundamentally very easy to set up. And then we have an open source testing framework, which basically has all of the API calls, etc., from across Azure AD, M365, Azure Cloud, AWS. So Halberd is a framework that we built that helps you simulate attacks easily and run them in that environment. So we can, our Vectra SEs can, systems engineers can help you with a guided lab experience. And you can essentially see this at work. You can experiment with it, build your own attack stories, and see how we do. So we would welcome all of you to try this out. So yeah, at that point, I think that's all I have in terms of prepared content. I hope I was able to give you a good flavor of what modern hybrid attacks look like, why they are hard to detect, how Vectra is able to streamline that and bring hours of investigation down to minutes, and then convince you of the breadth of capability that Vectra offers in the space. All this said, please trust me, but verify what you just saw. We can turn on a proof of concept in your environment at your convenience.